Hello, tech enthusiasts, friends, and families. Welcome to a new video. Today's content is a bit different from our usual videos. In past few weeks, our team has received numerous requests to create a video about microservices. In our last video, we talked about microservices. Today, we will discuss top 15 microservices interview questions you may encounter in any job interviews. Initially, we were hesitant about fulfilling this request, and we thought we will pass this request, as this is not our typical topic. However, considering the current job market situation where opportunities are very limited, we realized the importance of providing resources for job seekers to prepare effectively. In today's video, we'll also help you with the details and guidance to tackle these questions and answer effectively. Our goal has always been to assist our fellow friends, engineers, developers, and architects in learning new technologies and securing better job opportunities. So, why not extend our support to help them prepare for their job interviews? If you go to Google and search for microservice interview questions, you will come across numerous websites offering theoretical questions. Let me go to one. Maybe I'll go to Guru 99. I'll open Interview Beat. Even I'll open Udemy. If you'll see, it talks about explain microservice architecture. What is microservice? What do you mean by microservice? What is microservice? What are the advantages? So all those theoretical questions, what is monolithic architecture? However, I can guarantee you that you will rarely encounter such straightforward questions in real interviews. In fact, the chances are less than 2%. And these questions are often posed by interviewers with limited implementation knowledge who maybe have simply referred one of these websites. As I mentioned, the chances will be less than 2%. For today's session, the questions we have compiled are based on our experiences as recruiters and input from our friends and colleagues who regularly conduct technical interviews. If you are preparing for a job interview in this field, it's highly likely that you will come across one or many of these exact same questions or even very similar type of questions. This set will help you to prepare effectively for your interviews. Now let's dive into the top microservice interview questions and let me equip you with the knowledge you need to ace your next interview. The first question is, can you describe a real world scenario where you have implemented a microservice architecture? What are the key challenges you have faced? How did you overcome them? You can start with the scenario that you have implemented. It can be different for each and every one. It not necessarily whatever the scenario I will take, you have to mention. But please stick to the scenario what you have implemented. Maybe you can start with implemented a microservice architecture for a retail e-commerce platform, and then followed by provide a brief implementation details in 2 to 3 sentences. Then talk about the challenges, whatever you have faced. If I'll take an example, maybe you have faced challenges in service discovery and communication latency between the modules. Maybe you have faced challenges in monitoring and identifying the source of error because it's a distributed application component and that will lead to higher mean time to resolution. Now, what were the resolutions? You can containerize those applications using Dockers, and you can use Kubernetes for containerization, and that will eliminate the service discovery and the communication latencies. You can utilize Docker containers to encapsulate individual services, then facilitating easy deployment and scaling. You can implement Kubernetes for container orchestration. You can go for automated deployment, scaling, management of microservices across a distributed environment. Maybe if you have mentioned about monitoring and identifying those errors, or you have initially faced higher mean time to resolve, Then you can talk about Amazon CloudWatch, AWS X-ray, how you can get those X-ray tracing or how you can see those logs of distributed systems. Now, if you carefully observe, instead of asking what are the challenges of microservice implementation, these questions will be twisted to understand your capability or your hands-on experiences. My request would be please take a moment and customize the answer based on your use case and based on your implementation experiences. Let's move to the second question. How do you approach the decomposition of a monolithic application into microservices? Can you walk us through a specific example from your experience? Maybe you can start your answer and please specify a specific application or use case name without mentioning the client or the customer name for whom you have implemented. Maybe you can take an example of an e-commerce application, an insurance application, or an HR system. For our example, we'll take an HR system. Now let's start. To decompose the monolithic HR system into microservices, we used domain-driven principles and bounded context. Then we identified and separated the business domains within the monolith, such as employee management, payroll, benefits, etc. etc. And then we have created individual microservices. Then we have utilized event-driven architecture for inter-service communication that ensure loose coupling, flexibility, scalability, and resiliences. Now, if you observe this, the actual question or the underlying concept of this question was how to build microservice architecture. And you should consider giving a complete answer with sufficient implementation details. Please avoid using any terminology or concept that you are not completely familiar with, as this may lead to confusion and follow up questions, which can create rabbit holes. Most importantly, please remain calm, confident, and composed while addressing any interview questions. Now, as I mentioned scalability and resiliency, the follow-up question can be using the terminology scalability and resiliency. Let's review the next question. What measure you have taken to ensure the scalability and resiliency of your microservice application? Let's start with scalability. We used load balancing, auto scaling, and service health check. Since we are using microservice architecture, then VM are not the best choice for microservices. You can talk about using Docker containers to run your application. And for container orchestrations, you can talk about Kubernetes. Now let's talk about implementing fault tolerance. We can use exponential backups. We can use retries. We can use circuit breaker patterns or timeouts. Then let's talk about the caching at the database layer. If you are using API gateway, then caching at the API layers. We can mention about message queues like RabbitMQs, SQS queues for asynchronous processing. And then we can talk about monitoring and observability for early detection. Please mention the observability tools like Datadogs, Dynatrace, CloudWatch, or etc. whatever you have used. Now, if I'll take you to one of the architecture diagram where you can achieve the scalability and reliability, the architecture diagram could be similar like this. You have one user or the application user. The request will hit into the application load balancer, which will balance the load. Now your application is deployed using Kubernetes containers. That is, we have the pods. Now pods will be scaled based on the application load. For high load scenario, it will automatically scale the number of pods. When the load will go away, it will automatically decrease those pods. And then without interacting with the database directly, we have put a RabbitMQ or a message queue for asynchronous processing, such that no matter if my database is not able to scale, my messages will be there in the RabbitMQ and it will take a retry. Please make sure you are using idempotency in the application or when you are persisting the data into database. Now for the database also we have used a primary secondary configuration. My main database is the primary database, and then there is a secondary database that is for my high availability, and there will be automatic synchronization between the data from primary to secondary. So you should answer like this way, totally covering all the aspects. Please do not try to give half-cooked answer which will give you a negative credit. Now, before we proceed further, I would like to request you, if you are new to our channel or haven't subscribed yet, please subscribe to our channel and please click on the bell icon to turn notification for any future videos. If you like our effort, please like this video and share with your friends and families. Please drop your feedback for this video as a comment, and please let us know if you want us to create similar video for any other topics. Your support will encourage entire CloudExpert Solution team. Let's review the next question. In this question, it is asking, in your microservice environment, how did you handle authentication, authorization, and encryption? Security is job zero, and that is very important aspect. You can expect one question from security. Let's start with the authentication. You can start with authentication mechanism such as OAuth 2.0, OpenID Connect, or JWT, that is JSON Web Token. Next, talk about the centralized user identity management using an identity provider like LDAP, Active Directory, Tivoli, Okta, or even a custom user store. Then we have to integrate the authentication libraries or frameworks into each microservices to validate the token or handle user authentication. Now let's come to authorization. Here mention about the access control policies for the microservices. We can talk about role-based access control or attribute-based access control. You can talk about principle of least privileges. Implementing authorization in microservices involves defining access control policies for each service, specifying which users or role can access those specific resources. We can integrate authorization logic directly into microservices, validating access request before granting access. Then talk about the regular audit and review authorization policies to address security gaps. And finally, talk about the encryption. For encryption, ensure mentioning secure communication between microservices using protocols like HTTPS, TLS, SSL, and that will give you encryption in transit. Now let's move to our next question. Can you discuss a situation where you had to handle service discovery and communication between microservices? What tools or technique did you use? If you remember, this is a microservice design pattern, service discovery, and how you are communicating between different microservices. You can use APIs or you can use message broker. Now let's understand how you should answer this question. Start with tools like Netflix Eureka that will be used for the service discovery. And for communication, REST or gRPC for inter-service communication. Now we have to register microservices with Eureka servers for dynamic service discovery and load balancing. Then we can talk about utilizing RESTful APIs for synchronous communication between services. Then gRPC for high performance bidirectional communications in scenario requiring low latencies. If you want to talk about asynchronous communication, you can talk about message broker like RabbitMQ, Amazon SQS. One important aspect, if you haven't used Netflix Eureka or never worked with Eureka, please don't mention. It can bring follow-up questions related to Eureka configuration. And this is the point I want to emphasize multiple times. If you haven't used, if you haven't worked, do not bring that because you will create rabbit holes. Rather, you can talk about AWS Application Load Balancer. AWS Application Load Balancer or Elastic Load Balancer implements service discovery pattern, and it provides service discovery capability or even load balancing also. Or even you can talk about container orchestration services if you have worked instead of talking about Netflix Eureka. Now let's move to question number 6. What strategies you have used to ensure fault tolerance and resiliency in your microservice architecture? We can start with we have utilized circuit breaker and retries with histories to handle service failure gracefully. You can also talk about configuring histories. You can mention that you have configured histories circuit breaker to detect and isolate failing services that will prevent cascading failures. We can talk about implementation of Redis as distributed caches for frequently accessed data, and that will reduce the load on backend services and it will improve performance. And I assume that you know circuit breaker pattern. If you don't know, please go ahead and check what is microservice circuit breaker pattern. Let's move to our question number 7. It talks about how have you addressed data consistency and transaction management across multiple services in your microservice environment. We can start with we have utilized eventual consistency and compensating transaction pattern to maintain data integrity across microservices. We have also used Saga pattern for long running transactions. Now, if you do not know compensating transaction pattern, I would request you please go ahead and check that. A compensating transaction pattern is a set of database operations that reverse the effect of a failed transaction. For example, if a transaction transfer money from account 1 to another account, but the second account is unavailable, then a compensating transaction can return the money to the first account. Next, we can talk about we have implemented event sourcing and CQRS pattern for maintaining consistency between services, and that will ensure data updates are captured as event and stored in an append only log. We can also talk about we have used compensating transactions I told earlier to roll back changes in case of failure and Saga pattern for coordinating distributed transactions. I know in this example I have used multiple pattern like eventual consistency, CQRS, Saga pattern. Let's review them once. We'll start with CQRS or Command Query Responsibility Segregation. As the name suggests, here we are segregating command and the query. That means the write and the read transactions. Now we will have separate write APIs and separate read APIs. The database will have two separate nodes, one for the write transactions, one for the read transactions. Now, once the write request or the commands are coming from the application, it will first parses the data into the write node. Then write node will trigger an event and it will do the synchronization or it will do a eventual consistency write to the data into the read database, and then user will read the data from the read replica or all the query operations will be performed from the read database. Since this is eventual consistency, the user can see some stale data. But now before talking about eventual consistency, let's try to understand what is eventual consistency. Let's say in node 1, our client that is writing the data, and also once the client is writing the data, they will get an acknowledgement that the data has been written. There will be a synchronization or the eventual write propagation from node 1 to node 2. That means any new data what was written into node 1 will be eventually propagated to node 2. Because of this delay or because of this transactional latency, the client after writing a data, if it will try to retrieve the data from the node 2, it can see old data or the stale data. Now let's review the Saga pattern. Saga design pattern is a way to manage data consistency across microservices in a distributed transaction scenario. A saga is a sequence of transactions that update each services and publish a message or event to trigger the next transaction step. So as I mentioned, let's say you have service A. It has a local transaction. First, it will process the data into for service A into the local transaction, and after that it will create an event or a message, and that will initiate service B to do the local transaction for its service, and followed by it will again trigger a message or event for service 2 to do the persistency in its local transaction or the local database. Like that way, a saga design pattern, it will distribute the transaction sequence. Now let's review the next question, or question number 8. Can you share an example of how you have implemented versioning and backward compatibility in your microservice architecture? For this type of question, first talk about versioning. We can maintain multiple versions of APIs to support clients with different requirements. Then we have used URL paths or custom header to differentiate versions between version 1 of the URL, version 2 of the URL, and so on. Then we have implemented a consumer-driven contract testing with tools like Pact to validate that any changes to the APIs does not break the existing client. Like this way, when you will mention the mechanism along with the tool you have used, that will create a long lasting effort, and you will show your subject depth or subject expertise. Possibility of selecting you as the candidate will increase multifolded. Let's move on and review the next question. Describe a scenario where you had to handle eventual consistency and how you ensure data integrity in a microservice ecosystem. Let's first talk about the use case. Maybe talk about month-end processing when the application receives read query higher than average. And if you remember that we have discussed about the CQRS microservice pattern, where we are segregating the read workload from the write workload. And all the write or the command workload is going to a database node where it is responsible for the write operation. And any read query will be processed from a different node which is responsible only for the read transactions. We can talk about, we have implemented CQRS pattern or command query responsibility segregation pattern to separate read and write transactions. We have configured independent scaling and optimization of read and write operations. Now you can implement horizontal scaling, vertical scaling for your database nodes based on your transactional load. We have adapted event sourcing to capture all the changes from the write database to persist the change into the read database. Then we have implemented compensated pattern to maintain data integrity. If you remember, in last question we talked about the compensated pattern. And to summarize that, maybe we can say that we have applied event sourcing and CQRS pattern to achieve eventual consistency, and we have utilized distributed transaction or compensation pattern to maintain data integrity. By this way, you will be able to answer with brief and concise manner. Let's move on to our next question. Can you share an example of how you manage configuration and environment specific settings in a microservice architecture? To tackle this kind of question, first talk about the centralized configuration management. If you are familiar with Spring, we can utilize Spring Cloud Configuration or Spring Cloud Config for managing configuration settings centrally and configure microservices to retrieve configuration settings dynamically. To use environment specific configuration, we can talk about the application.property files, and there we can use @property source annotation. Now, if you are familiar, you have already used this kind of code segment where you have used property source annotations and then you have specified application with a variable spring config active, that and the variable value will be replaced to form the application.property names. Now let's say if you have used that property, the dspring active.profiles as test, during the execution your application property name will be replaced as application test.properties, and all those configuration will be fetched from application test.property files, not from other property files. Like that way, you can create multiple property files based on the environments. Now, if you are familiar with Kubernetes, you can talk about the Kubernetes config map to manage environment specific configurations and decouple configuration from application code. If you are not familiar with any of these, then you can talk about AWS SSM parameter store, where you can create parameters based on your environment, and dynamically you can retrieve parameters from the SSM parameter stores. So these are different ways. Please use any one of the examples what is applicable for you. Let's move on to our next question. How do you manage dependencies between microservices to avoid service cascading failure? We can talk about Istio. If you are not familiar with Istio, it is an open source service mesh that helps running distributed microservice based applications anywhere. We can start with that we have configured Istio to manage service to service communication that provide us feature like load balancing, traffic routing, and fault tolerant. Then we have implemented Envoy proxy as a sidecar container to intercept and control traffic between the services. Then we can talk about that we have utilized circuit breaker and timeouts for handling failure. This was my favorite question when I asked to the candidates. Most of the time, I got an answer that they have implemented circuit breakers. That's all. That is not giving the complete answer what an interviewer wants. So please make sure when you are forming that answer, you are giving to the point what the interviewer is looking for. Let's move on to our next question. Have you implemented CI/CD pipeline for your microservice based application? If yes, can you tell us what was the scenario? We can talk about that we have implemented Jenkins pipeline for our continuous integration and continuous deployment process. To start with, we have configured Jenkins pipeline to automate, build, test, and deploying microservices to Kubernetes clusters. We have utilized Helm chart to define, install, and manage application on Kubernetes. And we have enabled reproducible deployments and rollbacks. Now you can implement CI/CD pipelines using AWS CI/CD tools, Azure DevOps services. If you are not familiar with Jenkins or if you haven't configured Jenkins, you can take example or you can answer using AWS CI/CD tool or Azure DevOps. Your answers will be same. Instead of configuring Jenkins pipeline, you can talk about the AWS CI/CD tool where we have AWS code commit, code build, code deploy, and for the pipeline, we have AWS code pipeline. For Azure DevOps, we have Azure DevOps code repo, Azure DevOps pipeline, and you can form your answer using those cloud native CI/CD pipeline tool. Let's move on for the next question. Have you implemented health check and self-healing mechanism for microservices to ensure system reliability and availability? For this kind of question, start with health check. We have configured Kubernetes liveliness probes to determine the health of pod containers. We have utilized Kubernetes horizontal pod autoscaler to automatically scale the number of pod replicas based on the predefined health criteria. And that will restart containers if any one of the container become unresponsive. That will ensure high availability and reliability. You can notice how we are forming the answers. We are covering all the aspects in our answers and we are giving a 360-degree view of our knowledge and our implementation details. Let's move on. How do you design and implement effective logging and monitoring solution for microservices to facilitate troubleshooting and debugging? We can utilize ELK stack for centralized logging and monitoring. Now, ELK stack or Elastic Stack is a collection of 3 open source projects that allows you to aggregate, analyze, and visualize log from applications and system. The ELK stack, it is an acronym used to describe a stack for 3 popular projects: Elasticsearch, Logstash, and Kibana. Elasticsearch for log management, Logstash for log ingestion, and Kibana for dashboarding. So that is how we have implemented distributed tracing with JGear for troubleshooting and debugging. Then we can talk about we have configured FileBait to collect log from microservices and ship them to Elasticsearch for indexing and storage. We can talk about that we have integrated JGear with microservices to trace requests across distributed systems to identify latency bottlenecks and troubleshoot issue. Now, if you are not familiar with ELK stack, alternatively, you can use Amazon CloudWatch and Amazon X-Ray. You can talk that you have used Amazon CloudWatch to collect and trace matrices, monitor log files, set alarms, and automatically react to changes. We can also talk about X-Ray because X-Ray provides end-to-end visibility into requests as they travel through your application, and it makes easier to identify performance bottlenecks and troubleshoot errors because X-Ray will give you a trace request and the records detailed information about each component's performance. It will allow you to pinpoint the root cause of the issue with a visual representation. If there is an error, you will see that red color highlight there. You will be able to see what is the average latency that it is coming from each and every component. Like that way, you will be able to form your answer. If you are more familiar with CloudWatch X-Ray, use CloudWatch X-Ray. If you are using in other, maybe in on-premise system, there you can use ELK, where you have used Elasticsearch, Kibana, or even Logstash. Let's move on. If two microservices needs to update the same database, what is the recommended approach? We can talk about that we have used a distributed transaction coordinator like Apache Kafka or Zookeeper to coordinate transaction across services. And please remember that we should mention that we have implemented optimistic locking by attaching a version number to records in the database. If you are not familiar with optimistic locking, I will highly recommend you. Please go back and check the optimistic locking mechanism that you can implement for this kind of transactional atomicity. That was all for today. I believe you enjoyed this session and now you have an idea how the questions can be in 2024. And let me tell you again, whatever the answers or questions you are seeing in all those websites, only 2% chances that you will be asked as is questions if and only if the interviewer is also novice and he does not have an implementation expertise, or else 98% scenarios you can expect a scenario based questions which will be pinpointed or pointed towards to identify your implementation knowledge. That was all for today. If you like our effort, please give us a thumbs up and please share this video with your friends and families. Subscribe to our channel and please click on the bell icon for more content like this. Thank you for watching.